So hello, welcome today to SMTAi 2025 here in Rosemont, Chicago. This is the first official day of the show. It actually started last night between 3 and 7, but this is the first official day, I think.
4 and 7.
4 and 7? Oh yes, you're right, it was. It's between 4 and 7. So anyway, as you can see, I'm joined by my good friend Keith Bryant. So Keith, you've been attending a lot of the professional development courses upstairs, the keynotes, and yesterday they had a town hall. So maybe you can enlighten us on what that was.
Okay, well let's start with the keynote yesterday was really good on additive manufacturing in our industry.
Right.
And basically a cleverer way of putting tracking onto circuit boards, including hollow tracking that you can use for liquid cooling and this kind of stuff.
Wow.
So yeah, that was like, I would say brand new for everybody who was listening, for sure.
Well, that's interesting. And we'll be talking about liquid cooling in one of our panels later this morning. But I mean, using additive manufacturing for making jigs and things like that for our industry is becoming, pretty mainstream.
It has. I mean, these guys are printing tracking, they're printing all sorts of clever stuff, and they're doing some smart thermal bits and pieces as well. So It's moving forward, and obviously they're looking at other materials as well as copper.
Mm-hmm. Okay.
So yeah, it was, as I say, a lot of new stuff for the audience, for sure.
Right. Well,
that's all the professional development courses have been really well supported, 60, 70 people kind of thing, which
really?
Was better than last year and better than sort of the last few years.
Right.
The second day proper of the conference, again, very good numbers.
Mm-hmm.
I did a presentation in the Manufacturing for Excellence track on the Keiron technology, which was really interesting because there was only one person in the room that even knew what lift was.
Right.
But a lot of interesting questions afterwards. A lot of stuff I couldn't talk about because obviously it's very new and it's covered in patents. But yeah, a lot of interest.
Well, I mean, lift technology, frankly, as a technology, is not new.
No.
I think it stands for
laser-induced forward transfer.
Right. But and it's been used in a few different applications. But you've got this Keiron Companies, which is a Dutch-based company.
Yep.
Is going to be launching this at Productronica in a few weeks' time as a potential replacement for stencil printing.
Yeah, kind of. I mean, high volume product that's simple and easy and straightforward is always going to be stencil, because that's the simple, quick, cheap, easy way of doing it.
Right.
But if you've got boards where you need to use step stencils, boards where you need to jet extra paste on, or on the other side, boards with really small components where the aspect ratio of the stencil means all the paste doesn't release.
Yes.
Then it's a it's a shoe-in for that.
Really? Okay.
Yeah.
And what about and presumably for if you're doing a lot of high turnover,
high mix stuff, for sure.
Yeah.
Because you don't have to buy a stencil. If you need to do any modifications because you've got tombstoning or something, you can add extra paste where you need to, and basically it's a couple of clicks of the mouse.
Yeah.
So yeah.
No, I can't wait to see it. It sounds really exciting. So anyway, back to SMTAi, and you did a town hall.
Yes, we did a town hall yesterday afternoon on voiding at the end of a session which had 4 papers on mitigating voids, types of voids, and I did one on the challenges of void measurement.
Right.
And it was, we'll be polite and say it was a little bit contentious.
Was it? Yeah. I was just going to ask you, I mean, so what are the limitations of void measurement? I'm guessing if it's close to the intermetallic, it's difficult to,
Well, the premise of void measurement is most people are using 2D or 2.5D X-ray.
Right.
And the first thing that everybody needs to understand is X-ray machines don't measure voids.
Right. Okay.
X-ray machines measure grayscale.
I
So
see.
they measure literally the difference in the black
color.
and white color.
Yeah.
Yeah. And depending on how you set your machine up, depends on how you measure that.
What level of accuracy you're going to get?
And
Yeah.
you know, I've got some slides that prove that you can have plus or minus 8% on your void measurement.
Really?
Simply by messing with the settings on your X-ray machine.
Really?
Yeah.
Wow. Wow.
Yeah. And
But
then we got into what IPC accepts as a level of voiding, and the fact that it doesn't specify where the void should be, and there's some contention about where the voids, effectively where the crack path will run
Yeah.
if you have a series of voids in similar plane.
Yeah.
So yeah, that was all quite interesting. And then yeah, we had a town hall afterwards, which went on for half an hour longer than it was planned, and had some really interesting stuff, but also some very positive things. Of we got onto the potential cumulative damage of components by X-ray.
And what do you mean by the dosage levels?
Yeah, by the dosage levels, by if you've got an inline X-ray, is it more damaging than an offline where you just look at what you want to? And we ended up with my point, which I've always said is radiation in our bodies and radiation in anything is cumulative.
Right.
So unless you can put a sticker on the component when it's made that measures the doses that it has all through its life.
Well, that was what I was going to ask you.
Yeah.
Is there a way of actually tracking what the dosage levels are?
Yeah, Trevor, if I'd found one, I wouldn't be sitting here. But no, as a serious comment, there isn't at the moment. But of course, the better X-ray machines will tell you the dose that they're emitting.
Yes.
But it doesn't tell you the distance they are from the potentially sensitive component that will get damaged, or how long they're looking at that component.
Right.
So it's a help, but it's one of those things. If you've got a machine with a low dose mode where it switches down when it's moving, that's about the best that you can have. And as people were saying now, they're starting to see very sensitive components suffering damage.
Yes.
And a lot of people are doing quite a lot of studies on radiation damage.
Yes.
And unfortunately, as I said to them, that'll work within your facility, but you don't know how much radiation damage it gets beforehand.
Right. Well, this is it. I mean, because when you bring components into the factory in the first place, a lot of people start to use these component counters. That's an X-ray dosage right there.
Yeah, but also your manufacturer's using one.
Yeah.
Your let's say your main distributor is using one. Your local distributor is using one. Your goods inwards is using one. And then every time the batch of material that you're using goes back to be booked into the stores, it's going through another component counter.
It's incredible. Yeah, I know. It's amazing. They could almost glow in the dark.
Oh, yeah. Yeah.
Anyway, fascinating stuff. A lot of things happening here today, obviously on the show floor. We've got a couple of panels coming up. So, but for now, I want to thank you for your wise words, and thank you to our audience for joining us.
Welcome to the grand unveiling of the Void humanoid assembly line. Faster, smarter, and definitely not terrifying.
These robots replace outdated human operators. Who needs job security when you can have precision soldering at 5,000 joints per second? Let's watch as Voidy assembles a state-of-the-art PCB.
Step 1, pick and place.
Just a little learning curve. I guess he needs to read global SMT and packaging.